This is DesignSafe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
Hey, we're back on DesignSafe Radio, and we're talking with Mike Motley, Abbey, and Dakota from the University of Washington, having a great discussion about tsunami debris and the research that they've been doing at Oregon State University's wave flume. Let's jump back in. So your research is as best I can understand it, about how debris from tsunami interacts with structures and kind of quantifying that. So can you tell us a little bit about what happens in a tsunami to create all these big and little chunks of things, and how the kind of current state of research is around that topic?
Yeah, so I think that over the last 15, 20 years, we've seen some of these tsunamis that have happened in 2004, 2010, 2011 across the Pacific, and we've seen that you get this large-scale devastation, water's rushing in, and as the water's coming in, it's picking up basically everything that it comes into contact with that is not tied down very well. And so debris can be anything. I think sometimes when we have debris in our heads, it's trees and branches and things like that. But for us, we're talking about cars and boats. And, in Hurricane Katrina, some of the debris were casinos, right? Because they're floating on the Mississippi.
Oh, yeah.
Out there.
Wow.
And so, the scale can be quite disparate. And so trying to figure out what we can do with that. And in addition to that, we see that, houses and things like that basically turn into their individual components as the water comes through, and it creates this sort of giant field that's going to move through and change the fluid dynamics, change how everything is operating. And so what we kind of looked at was that there was quite a bit of work being done on how an individual piece of debris or a very small subset of debris would load a structure, and those experiments were very controlled. There were things, there's data out there on logs, there's data, a lot of stuff on shipping containers. That seems to be where a lot of the effort is focused. What we decided to do, we had some experiments about 4 years ago down in Oregon State at the lab, and spent the last 8 days doing proof of concept that we could actually see what it would look like if we just sort of arbitrarily put some debris into the flume. It worked, and that turned into this test where we ended up doing 400, how many?
I think 410 good tests.
410.
More or not as
wow.
Yes, and so we had initially proposed 250, and Dakota and Abbey knocked it out of the park. We got 410 waves picking up debris, taking them into the structure, and basically trying to, we're never going to simulate what it actually looks like out there. But when you're watching the videos, it's rare that you see a car, on wires hitting the structure by itself directly with sort of a frontal impact. And so I've kind of described this as embracing the chaos and trying to see what we can do there. And then, from now to really dive in and start looking at this a little bit more systematically from a statistical point of view. I think that's really where we're going to get something and start trying to see how can we predict some type of a load on a structure when if you take a house and reduce it to all the individual pieces of the house and it hits a structure, what does that loading actually look like? Because it's not going to look exactly like ramming a shipping container into it.
Yeah. So can you tell us a little bit about the experimental setup at Oregon State for those who aren't familiar with the wave flume and kind of how things are set up there, the scale? I mean, it's huge, and the types of things that you're able to do there in those 410 odd runs.
Yeah, so I'll talk a little bit about the facility itself. It's you can go online and see the live footage. Oftentimes the live footage is just sort of it looks like a long thin pool, but things are happening down there, and it's 120 meters long, I believe, and there's a piston at one end that moves the water and sends a wave or a series of waves, and then we designed the bottom of the flume or the bathymetry of the flume. So we turn it into a concrete beach, essentially, to make the waves break where we want. And then there's we call it the orange box. So there's a structure about 1 meter by 1 meter by 1 meter that's sitting there in the middle. It gets impacted by the wave or the debris. And so, from there, we've got pressure gauges and load cells and wave gauges, velocimeters. And then the challenge became, how do you get the debris to hit the structure? And so
and repeatedly, I imagine.
So I think that it makes sense for Dakota and Abbey to take off a little bit, because there was trial and trial and trial and error and error and error, but we finally got it. And so you guys want to talk a little bit about all the different ways we tried?
Yeah, sure. So I think the initial, when we did the testing 4 years ago, the initial frame, you could say, that held the debris in place in the flume was kind of just this wooden structure that was 2 by 6s kind of nailed together, and then essentially would float on the surface of the water, and then you put these neutrally buoyant pieces of debris. They're made of high density polyethylene, so it's by design neutrally buoyant. It stays on the surface of the water, and you would just kind of throw that in the square initially, and when the wave came, just kind of time it visually and lift the frame out of the water so that it's free floating by the time the wave impacts the debris.
So it's kind of like setting up for a breaking, a break in pool or something. Sounds like.
Yeah.
And so that was the initial design. We kind of took and expanded that. The other idea that came up within the design process was making the debris themselves magnetic, so that they could be attached to a frame that had electromagnets on it. The idea was that it would be, it would maintain an initial condition, or would randomize the initial condition based on the parameters that you wanted. And so we tried to do that. One of the things that we didn't account for was the fact that steel is pretty heavy, and the debris would sink with steel in it. So that was one challenge we had to work through a bit on the ground, but that's why we hired Abbey, brilliant at problem solving, and we worked through that there. So, yeah.
Cool.
Yeah. So there were iterations of the magnets, and then it was the little things you don't think about, right? We forgot that adding a small magnet changes the neutral buoyancy slightly, and things.
You probably had them sticking to the specimen once they got there.
Yeah, and we didn't think about what it would be like putting them back underneath. Right. And so then there was the issue of how do we do that? And so in the end, it was a balance of the two approaches. And we got, I think in the end, the magnet setup, which we had designed for consistency, gave us a lot more randomness than we had wanted. But I think that we're starting to work through a little bit there. And so in the end, it's drop the debris, run the wave, it moves the debris into the structure, and then we go and collect it. And Abbey and Dakota go. I did it 3 or 4 times, and so they got some photos. And I can claim that I was helping, but for the most part, it was Abbey and Dakota chasing them down and setting them up, and got pretty good at that by the end.
I imagine you're like down there with a net and waders or something.
Yeah, exactly. Waiters. Yeah, we encountered some interesting. I think Abbey and I really did a lot of character building at the Flume. Abbey, in particular, I hired her to help me with the getting into cold water with waiters part of the project.
Yeah.
And so we spent a lot of time getting in and out. And like Mike mentioned, with this particular electromagnetic frame, I guess is how we can refer to it. It was fairly close to the water surface in an attempt to maintain consistency when the debris dropped and hit the surface. So working underneath it, obviously it was reinforced and it was safely attached, but it was a bit of a how would you describe it, Abbey?
Well, it was a challenge. Character building challenge, I think, is the right way to put that.
Yeah, the debris itself each weighed about 2.5 kilograms. So, and we had up to 24 full-size 2.5 kilograms debris at a time. So each test we were moving a lot of pieces.
Thanks for listening to today's episode of DesignSafe Radio.
This show is sponsored by the National Science Foundation, grant number 1612144. You can subscribe to DesignSafe Radio on iTunes, Stitcher, or wherever you find your podcasts. Please leave us a review so we can improve the show. Please also help others find our episodes in iTunes. Thanks for your feedback and support. You can find out more about NHERI at designsafe-ci.org, on Facebook at DesignSafe Radio, or on Twitter at NHERI DesignSafe.